Okay, is the screen visible now?
No, ma'am.
No, ma'am.
No.
Now it's visible, ma'am.
Okay. Now, today I will just share you some of the things that I know about what are the careers in mathematics, because this is what a fourth semester after this you have to go to the world where you want to get a job and all, right? Or unless otherwise, if you want to do any business, in that also we needed some logical things which a mathematician can apply a logic to anything very फाइनली एक्सेप्ट अगर कोई और लॉजिकल रीजनिंग देना चाहता है तो मैथमेटिशियन एंड some another person there is some difference and we can apply the logic very easily, correct? So that's why just something I will share for you. For that we have many careers in mathematics except teaching also, okay? We'll see some of the common views about the mathematics, right? First one is mathematics is hard because no doubt the peoples who are going to study the mathematics in suppose in your school, okay, this many students have the difficulty that they are not much more familiar with mathematics. They seem having some problem with mathematics, like how to remember the formulas and some different problems are there. The second one is maths is boring. Some people say this. Uh, Next thing is very important. Maths has nothing to do with the real life. Just like suppose whatever the theorems we are going to study in this, no doubt in MSc or BSc anywhere else, they are not having any real life situations or it is not having any use in real life. They are saying that they have no use in real life, but we can say that there are some uses in real life, or rather many applications are there. Just like if the current research is there, fluid dynamics is there, fractional differential equation is there, Galois theory is there. Every these type of research have the some real life application. That's why it is accepted now. Just like suppose if you want to have a fractional derivative in all, it has a many applications in engineering. No doubt mathematics do not have a direct application in real life, but it have indirect application. It is used in chemistry, physics, even in the fluid dynamics is having a real life situations. That means in fluid dynamics means what, we are having some different type of a liquid. Suppose it is water, honey, mercury. These type of a liquid, when they are going to flow, we are going to observe their nature. That means what will happen after some time, whether the speed reduces, and if it is the word speed is used, where acceleration is used, we have to use a mathematics, because velocity is nothing but the rate of change of a displacement, and what is acceleration? It is rate of change of a velocity. So how you're going to find out the rate? You must go to the mathematics, because unless and until you don't know a derivative, how you're going to find out the acceleration and velocity, correct? So you can say that there are many of the real life example. No doubt fluid dynamics is a part of a physics, but many of the things they are using, just like a derivative, partial derivative, PD equations, just like IBP. That means with the help of those conditions, they are going to use, they are going to evaluate what is the nature of the that fluid. It may be any type of a fluid. There are so many fluid. They are going to just observe the nature of those fluids, right? So this is what the thing you can say, that there are so many real life examples, real life applications, not directly, but it may be indirect. Um, the next thing is all mathematicians are mad. Some people say this, but I don't know whether you got this or not. Okay. Now we are going to see what are the applications in mathematics. Say we can have a crime detection, medicine, all these type of things. And first one will go through mathematics and crime. Okay, so no doubt this in this way अभी तो ये ज़्यादा यूजफुल नहीं है, बट व्हेन इट वाज द थिंग लाइक सपोज आपके पास उतना अच्छा कैमरा नहीं था उस टाइम पे, तो उस टाइम पे इसका बहुत ज़्यादा यूज था, राइट। सपोज एक रॉबरी हुई है बैंक में, तो एट दैट टाइम वी कैन हाँ पुलिस टेक अ फोटो ऑफ दैट, जो भी कार या बाइक वो जो भी लेके आए थे उसका फोटो लिया, बट वो ब्लर्ड आ गया। मे बी ड्यू टू सिचुएशन अभी भी ब्लर्ड आ सकता है फोटो, क्योंकि सपोज हमने कोई सेल्फी ले ली या कोई कोई भी फोटो अगर आप लेते हो, तो अगर थोड़ा सा ऐसे हिल गया कैमरा तो नो डाउट ब्लड आता है फोटो, राइट ना।
Yes, ma'am.
हाँ, सो समटाइम फोटो ब्लर्ड जब आता है, उस ब्लर्ड इमेज को कैसे आप रिकॉग्नाइज करोगे, क्योंकि यहाँ पे तो रॉबरी का केस है ना, बैंक रॉबरी। सो एट दैट टाइम the solution was given. We have a model, that means the blurring process we can remove. Okay, the first we are having a original image we have to do, and then blurred image we can have. Okay, blurring formula, that means here we can have, with the help of this formula we can convert this blurred image to a good one, that means with the help of inversion formula। यहाँ पे क्या है, blurring formula, और यहाँ पे क्या है, inversion formula। No doubt this formula is somewhat difficult, but we can apply and we can have, say this is what your h of x is a function whose and we can, after applying this one, that means after solving this equation, this is what your h, that is a blurred image, and f is what your image which is not blurred. Okay, after applying these operations we can have this f of x is a, now you can see the image, दिसतंय ना सगळ्यांना?
Yes, ma'am.
So this is what a formula. Initially it is blurring formula. Next is inversion formula will give you the correct image. Okay. This is what an actually example of a image processing. Many of the applications of image processing in that means research is going on in image processing. The main part it used in image processing is the matrices and integration and all. So you can search for this if you want to do. Suppose आपको अभी project भी करना है ना, you can do a project in image processing, how the formulas are applied in image processing, which applications, rather which uh, things of mathematics are used in image processing, right? कंप्यूटर साइंस में बहुत ज़्यादा इमेज प्रोसेसिंग का यूज होता है। मे बी यू कैन सर्च फॉर हेगड़े सर, सबको हेगड़े सर पता होंगे?
Yes, ma'am.
हाँ, सो हेगड़े सर के जो भी स्टूडेंट्स थे, जिनको विश्वेश्वरैया से फेलोशिप मिला था 55 लाख का, तो उन लोग को मोस्टली दे आर वर्किंग ऑन इमेज प्रोसेसिंग। So you can search on a Google Scholar related to हेगड़े सर, and you can go through the research paper, और उन रिसर्च पेपर में आपको मिलेगा कि मैथमेटिक्स का क्या यूज किया है उन्होंने। एक्चुअली आई ऑल्सो डोंट नो एग्जैक्टली, बट मैं सिर्फ सिंपल आइडियाज दिखा रही हूँ कि मैथमेटिक्स के बहुत सारे डिफरेंट करियर्स भी हैं, जस्ट लाइक इन क्राइम डिटेक्शन, यहाँ पे भी यूज आपका हो सकता है। डोंट थिंक दैट वी हैव टू गो टू टीचिंग इट्स। We are having some applications in TV, DVD, computer graphics. Computer graphics में तो बहुत ज़्यादा यूज होता है मैथ्स का, स्पेशल इफेक्ट्स। So images are stored as a number. That means, so suppose we have any image, so it this image can be stored as a number. आप भी अगर आप कोई image लेते हो, तो आप देख सकते हो उसके डिटेल्स में आप जाओगे तो वहाँ पे एक नंबर ही होता है। जस्ट लाइक suppose if you capture one image, I can show you. Actually मुझे दो स्क्रीन यू कैन सी ऑन योर मोबाइल इटसेल्फ। अगर आप कोई भी इमेज या कोई भी सेल्फी या कोई भी फोटो लेते हो, अगर आप उसके डिटेल्स में जाओगे ना, वहाँ पे ऐसे कुछ नंबर आता है, no doubt date is there. After that we are having some number. दैट मीन्स वो जो इमेज आप कैप्चर कर रहे हो उसको एक नंबर के फॉर्म में वो मोबाईल या कम्प्युटर रीड करता है. करेक्ट. बघितलं ना सगळ्यांनी.
Yes, ma'am.
So that is what an application of mathematics. That is mostly real life application. आप अगर कोई आपको ऐसे बोलता है कि मैथमेटिक्स का कोई रियल लाइफ एग्जाम्पल है तो आप उसको ये एग्जाम्पल दे सकते हो. अगर किसी ने बोला तो उसका खुद का ही मोबाइल ले लो कि आप कोई पिक्चर आपके मोबाइल में है तो उसका जो भी डिटेल्स में जाओगे तो वो एक नंबर होगा क्योंकि इमेज को कोई भी कोई भी कंप्यूटर या मोबाइल रीड नहीं कर सकता. वो क्या रीड कर सकता है सिर्फ नंबर्स. राइट. जस्ट लाइक अ बाइनरी सिस्टम. अपना जो भी कंप्यूटर सिस्टम है इट इज बेस्ड ऑन बाइनरी नंबर्स ना 0 and 1. So whatever the images we are going to take that is stored as a number. Right. So these are the things. यहाँ पे भी आप जो कार्टून्स वगैरह देखते हो उसमें बहुत सारा मैथमेटिक्स का ही यूज होता है. कंप्यूटर ग्राफिक्स में बहुत नो डाउट आपने बहुत सारे कार्टून्स देखे होंगे आपके चाइल्डहुड में. वहाँ पे मोस्टली अपने मैथ्स का ही यूज होता है. जस्ट लाइक या गैल्बा थ्योरी का. And let us see for what is a use in mathematics. Okay. So in ultrasound, MRI, CT scan, I don't know exactly what is the use, but I have just found the ultrasound में क्या है sound waves है. Sound waves का nature कैसा होता है हमें तो पता है right. At least we can see the nature of waves we can detect and magnetism. This is also used in X-rays में भी बहुत ज़्यादा used होता है right. So these are the things. ये sound waves को हम read कर सकते हैं ना. So that's why we can say that it has a applications in medicine also. Okay. So here also there is some applications. I don't know exactly how they are going to apply, but we can at least say that we have some real life application. You can see here over 90% of jobs are required mathematics because if you go for banking, MPSC, UPSC, if you want to give any type of a exam, at least one paper is there. The name may not be mathematics, but it may be aptitude. At least the name is aptitude, or some of you may gone through some campus interview. Those who were from Walton College and all, Infosys का भी इंटरव्यू होता है. आई थिंक इंडिया बुल्स बहुत सारे कंपनीज हमारा इंटरव्यू लेते हैं ना. दोज हु आर फ्रॉम वॉल्सन कॉलेज. आई होप दे नो. माहित आहे ना. हॅलो.
Yes, ma'am.
बीएससी मध्ये झालाय ना. वॉल्सनचे कोण आहे.
Hello.
Okay. So actually they are having some criteria to select the student, or suppose if you go through MPSC, UPSC and all, वहाँ पे भी एक aptitude या mathematics का logical reasoning. The name may be different about the paper, but it is mainly related to mathematics. They are having some logical conditions and all. So 90% of jobs are required in mathematics. You can see this mathematics graduate on more than any other profession. But इसके लिए आपको खुद का पड़ेगा. Nowadays it is most important one is a stock market and share market. वहाँ पे mathematics का tremendous use है क्योंकि logical reasoning और प्रोबेबिलिटी को फाइंड आउट करना या फिर किस शेयर का प्राइस कितना लो हो रहा है और उसके एक्सपेक्टेशंस क्या है. लास्ट 4 to 5 मंथ्स का डेटा कैलकुलेट करना, उस पर से प्रिडिक्ट करना, ये सब चीजें मैथमेटिशियंस बहुत अच्छे से कर सकते हैं. राइट ना. We are
Yes,
having
ma'am.
okay. So you can even go for you can download any of the app which is related to share market and all. तो आप एक साल भर स्टडी करो और आप प्रिडिक्शंस कर सकते हो. और जो मतलब जो शेयर मार्केट में अपना मतलब इन्वेस्टमेंट करना चाहते हैं तो उनको अगर आप सजेशंस दोगे, नो डाउट इफ यू आई डोंट नो हाउ मेनी ऑफ यू आर नोइंग और नॉट, इफ यू फ्रॉम अक्रॉस दैट ऐश्वर्या होटल नियर स्टैंड, वहाँ पे एक आपने देखा होगा एक पर्सन है जो सिर्फ आपको इन्वेस्ट किस शेयर में करना है ये बताने के लिए भी वो पैसे लेता है, राइट? और दैट इज व्हाट मोर, इतना कम भी पैसे नहीं लेता है, बट you can have this type of a thing also. शेयर मार्केट में बहुत ज़्यादा प्रिडिक्शंस का यूज़ होता है, राइट? आई डोंट नो हाउ मेनी ऑफ यू नो अबाउट दिस दैट जिन लोगों ने लॉकडाउन में शेयर मार्केट में पैसा लगाया उनका अभी शेयर्स का रेट बहुत ज़्यादा हाई हो गए। जस्ट लाइक इफ सपोज समवन हैज़ 10 लाख, अगर उसने पूरे 10 के 10 लाख अगर शेयर मार्केट में लगाए लॉकडाउन के पीरियड में, सो आई विल टेल अबाउट सम ऑफ द थिंग्स। आइडिया का जो शेयर था उसका 3 रुपये कुछ प्राइस था, और यस बैंक उसका भी बहुत प्राइस लेस था इन द टाइम ऑफ लॉकडाउन, एंड इवन अबाउट SBI एंड रिलायंस, बहुत सारे शेयर्स का प्राइस बहुत ज़्यादा लो हो गया था लॉकडाउन के पीरियड में। But at that time, some people were worrying about this, that whether this price will be.
Hello, ma'am.
हाँ,
Ma'am, Deshmukh madam is waiting for your joining.
what is the problem?
ते जॉईन करत आहेत मॅडम पण जॉईन होत नाहीये.
एक मिनट, हाँ. Let me think. आता सांगा त्यांना. Tell your friends those who are waiting. I have Madam joined right now. Okay, so we were discussing that on an average, जो भी शेयर मार्केट में जो भी प्राइस उन्होंने लगाया था जिसने लॉकडाउन के पीरियड में, so at that time they were thinking whether the price of share will be low, or it may be increase after the after unlockdown, right? So at that time the people who has applied और जिसने इन्वेस्ट किया है वो बहुत ज़्यादा प्रॉफिट में, right? And next thing we can have the things in accountancy, actuarial studies, many field are there where you can go. Next is without mathematics we cannot have mobile phone, internet, credit card. The main thing I want to tell you about the debit and credit card. ATM use करते हैं सब लोग?
Yes,
ma'am.
At least one time you have used, no? So whenever you are having ATM, suppose if you want to, अगर आपके पास नया ATM है, suppose first time you have, so at that time you will be provided with that PIN number, no? एक पैकेट होता है उसके अंदर एक PIN नंबर होता है, करेक्ट?
Yes.
टाइम आप जब अप्लाई करते हो किसी ATM में जाके, तो एट दैट टाइम दे आस्क फॉर OTP. Rather, OTP is now common for everything. Whether you know which technique they are going to use in OTP, क्योंकि वो भी एक नंबर्स है ना, they are going to generate a number, that OTP is sent to our phone number or our mobile number, and then with the help of that we are they are going to verify that it is you only. That means आप ही use कर रहे हैं, right? So at that time, whatever the PIN number or OTP is going to generate, at that time they are going to use a mathematics also. In that, mainly the case used is a number theory. ओके, मोस्टली ऑड नंबर का कुछ कैलकुलेशंस है, मैंने पढ़ा था, अभी फिलहाल मुझे एग्जैक्टली याद नहीं आ रहा क्योंकि नंबर थ्योरी मुझे हुआ नहीं है, मतलब हमारे टाइम पे नंबर थ्योरी था नहीं. सो एट दैट्स व्हाई आई डोंट नो एग्जैक्टली विच applications of number theory are used in generation of OTP. I have studied this. Thus, things was given at that time was they are going to use some techniques on odd numbers. Okay.
Ma'am, number theory is also used in the check digits in barcodes and other cards.
Right. They are used in many of the applications. नंबर theory के बहुत सारे applications है, बारकोड में होता है और OTP में भी यूज होता है और बहुत जगह different use है. So I also want to study that. DNA में भी बहुत ज़्यादा यूज है. Maths is vital working on पेमेंट्स, यहाँ पे आप भी कोई भी टाइप का पेमेंट करते हो. सपोज इफ यू वांट टू बाय एनीथिंग फ्रॉम अमेजॉन, फ्लिपकार्ट, you are having a OTP and that OTP is mostly calculated through number theory. Okay, so these are the careers in mathematics. जो भी हम चीज़ें छुपा के रखते हैं, जस्ट लाइक क्या बोलते हैं उसको, नहीं एग्जैक्टली डोंट रिमेम्बरिंग दैट. हिडन मटेरियल्स को फाइंड आउट करने के लिए भी होता है. Find the trick wires in the pictures. With the help of X-ray, you can transform this. These are what simple applications of mathematics and careers in mathematics. I just want to say you this because after the completion of MSc and all, you may be going for a job. So that's why I told you that there are some applications of mathematics and some of the job related to mathematics which is not about the teaching. टीचिंग छोड़ के भी बहुत ज़्यादा अपने पास चॉइस है, तो आप वहाँ पे भी जा सकते हो, right? So hence now let us go for our syllabus. So let us go for the first one, that is a symmetric kernel. With the help of symmetric kernel, we'll solve some of the theorems. Okay. Before going to symmetric kernel, I want to ask you whether you know symmetric matrix entries. Skew symmetric. Matrices, types of matrices.
If a matrix is equal to its transpose, then it is called a symmetric matrix.
That is what a property of a symmetric matrix. Huh? But
Yes,
what is
ma'am.
actually how it is defined, symmetric matrix? No one is knowing about what is a symmetric matrix. It's shocking for me itself. Linear algebra झालाय ना?
Hello, ma'am.
बोला.
A square matrix A is equal to Aij is said to be symmetric matrix if Aij is equal to Aji, if
अच्छा.
A is equal to A transpose.
That means if A is a matrix which say of order is n cross n, so in that case, if Aij is equals to Aji for all I in j, then it is called a symmetric matrix. But what is Aij? These are nothing but here. Suppose here I will take a very only 2 cross 2 matrix. So it is A12. So Aij is equals to Aj means what? A11 that is A12 should be exactly equal to A21. Okay, these numbers whatever we have. Suppose here is 2. Here it should be again 2 and A22. Okay, there is no anything about the A11, A22. That means we are not bothering about the diagonal element. Simply we are restricted to non-diagonal element. That means Aij should be exactly equal to Aj. Okay. So in the very similar way, we have defined a symmetric kernel. Okay. So what is a symmetric kernel? A kernel is called a symmetric if it coincides with its complex conjugate in case of we are having a complex numbers. So we can say it is k of xt if it is exactly equals to k bar of tx, then it is called a symmetric kernel. Okay, the bar denotes a complex conjugate. I hope you are knowing about z and z bar. What is z? If it is a complex number, it is of the form a plus ib. What will be z bar?
A minus IB.
A minus ib. So this is what a complex conjugate. So if suppose we are not bothering about the complex number, that means if you are only restricted with the real one. Okay. So what will be the effect if we want to say a symmetric kernel on a related to only a real number system? We are not bothering about the complex number. So it will be simply k of xt is equals to k of tx. Correct? Just like aij should be exactly equal to aji. Okay, if it is a real number. But here, if it is complex number, k of xt should be exactly equal to k bar of tx. Right? If z is equal to z bar, what we say z is a real number. Correct, na? Z is equal to z bar.
Yes, ma'am.
It is a real number. Okay, so here also, if we are having only real numbers, so we can say kernel is called a symmetric kernel if k of xt is equals to k of tx. And now we will see some of the theorems or some of the definitions first we'll see. After that we'll go for the Friedel operator and okay. The first condition which we are going to see is a regularity condition. Okay. A square integrable function f of x such that a square integrable function means what? Integrable means say it is with some integration. Square integrable means f of x square is integrable means what? It is strictly less than infinity. It should be some finite number, no? Integrable means इंटीग्रेबल का मीनिंग पता है ना सबको? रीमन इंटीग्रेशन.
Yes, ma'am.
Yes, ma'am.
Integrable means what? The whatever the value of integration it is getting, it should be some finite number. So that's why we can say the square integrable function means we can say it is strictly less than infinity. Next we will see is a L2 function. A regularity condition on the kernel k of xt are identical and it is called a L2 function if the following three conditions are satisfied. Okay. Regularity condition on a kernel k of xt are identical and it is called a L2 function if the following three conditions are satisfied. First condition is integration a to b k of xt square dx dt strictly less than infinity on the condition x and t both belongs to closed interval ab. The first condition. The second one is integration a to b k of xt its square dx is less than infinity. Again the condition x belongs to the closed interval ab. And here integration k of xt dt is strictly less than infinity on the condition t belongs to closed interval ab. Okay, so these are the things given to us at the kernel for kernel k of xt. What is called square integrable function if it is of this form? Okay, square and integrable. And if this condition is applied for kernel, then it is called a L2 function. Okay. These are simply definitions, easy to understand. Next one is a inner product. Okay, suppose we are having the two complex L2 function phi and psi. We are having two L2 functions. Say first one is phi and psi of a real variable x, and the inner product of these two is denoted by you will understand this one easily if your Hilbert space is done for you. Chala hai na Hilbert space?
Yes, ma'am.
Yes, ma'am.
In the Hilbert space, we have an inner product space. In that, if suppose we have two complex numbers, suppose how you are going to denote that? Can anyone tell me what are the properties of inner product space? Hello? What are the properties of inner product space? Is it so difficult?
Ma'am, it is greater than or equal to 0 and if
Hmm.
xy is equal to, it is
Ah,
symmetric.
may I write this as u comma u?
Okay, ma'am.
तुमचे notations काय होते functional?
X and Y, ma'am.
Okay, let me write down this as x and xy greater or equal by 0. What is second condition?
X and Y is equal to 0. X and only X equal to Y.
Yes, ma'am.
Xy equal to 0 if and only if.
X is equals to y.
Okay. That means we can say inner product of x with x is 0. Right. Third one.
Conjugate.
Xy is equals to yx. In the product of.
Y is
Inner
conjugate.
product of xy is equal equal to inner product of y.
Yx.
What is the fourth one?
Inner product of xy is equals to
Hmm.
I'm exactly not remembering it is equal to or less than or equal to.
Okay, you tell me what is the fourth property simply.
It is triangular inequality.
Triangular inequality, that means it should be less than or equal to. Next.
Yeah, inner product of x comma z
Hmm.
plus z comma y.
Yes, anyone else having any issue about these four properties? असंच होतं ना इनर प्रोडक्ट बोला आता तरी फोर्थ सेमिस्टर आहे याच्यानंतर
Yes, ma'am.
Hello, ma'am.
Ma'am, in
Hello.
third
I think this is matrix space properties.
मग इनर प्रोडक्टचे कुठले आहेत प्रॉपर्टी
x is greater than equal to the 0 असायला पाहिजे आणि दुसरं inner product of x is equal to 0 जर असेल तर y हा एक्सपेक्टेड बरोबर आहे थर्ड मध्ये inner product of x y बार equal to inner product of y x पाहिजे आणि फोर्थ मध्ये inner product of alpha x plus beta y z असं काहीतरी होतं फोर्थ एक पण थर्ड मध्ये inner product of x y बार is equal to inner product of x y x पाहिजे
दिस वन इज करेक्ट ना एक्स वाय इज इक्वल्स टू बरोबर आहे ना
y bar should be there, ma'am. Yes.
x
Y
बार
bar, ma'am. Conjugate.
ओके अजून
फोर्थ प्रॉपर्टी मध्ये इनर प्रोडक्ट ऑफ अल्फा एक्स प्लस बीटा वाय झेड पाहिजे इक्वल टू अल्फा
हे रॉंग आहे ना इथे हे आलं पाहिजे प्रोडक्ट ऑफ
इनर प्रोडक्ट ऑफ
v plus w. Suppose it is x, y, z if you want to write. It is exactly equal to uv plus uw. असंच आहे ना
Yes, ma'am.
नेक्स्ट c times uv is equals to cuv. Still anyone having any problem related to inner product properties? Bar is for whole, no? Not for simply x. Okay, these are whatever the things you have studied about a Hilbert space, rather whole functional analysis. In that, your codomain was restricted to R or C. Remember this?
Yes, ma'am.
So that's why it is restricted to rather real number or complex number. So, but if we are having simply real numbers or complex number, then it is okay. But if you are going to define for any function, because here we are provided that phi psi are function, right? Instead of having any real or complex number, if we have a function, the definition of inner product is like this: inner product of phi with psi is equals to integration a to b phi of x into psi bar of x dx. Okay, this is what a definition. Okay, now let me ask you one question. Can you please tell me what is a third property? This inner product of xy is equal to inner product of ix bar. Why this is so? We are going to change this, it will be bar. if you're not going to give any response, you have to think that why the definition is defined like this. Inner product of phi with psi is nothing but integration a to b phi and psi bar of x. Okay. Um, just I will give a hint for you. The suppose we are having any two numbers or any inner product if you want to define, whether you have written in the form of summation of say xi yi, where I runs from 1 to n. If you remember this one, try to think why the definition of inner product with phi inside, that is a functions if we have, the inner product is defined in this way. Okay.
Okay, ma'am.
And you have to find out the answers. Okay. हे तुम्हाला आन्सर का देता आले नाही माहिती का? तुम्ही केलेच नाही अभ्यास, बरोबर ना? फक्त बनाच स्पेस वाचलेत का? Have you studied Hilbert space, inner product space? Because if you have studied Hilbert space, obviously you should know what is inner product space and all. There are so many properties with, in that we are having this condition. With the help of this condition itself, we can go for how to define the inner product with the functions. Okay. Don't think that if you are going to appear for a MCQ type of exam, you know to go through the theory. Okay. अगर आप थ्योरी पढ़ोगे तभी आपको आगे कुछ यूज होगा ना. Okay. Now let me go for the next one that is also known to you people. What is the relation between norm of x and inner product of x?
Square root of the inner product of xx.
Square root of inner product of x. X is nothing but your norm. Which one implies which? Whether inner product, every inner product is norm or every norm is an inner product? Do you remember this one? Every Hilbert space is a Banach space.
Yes, ma'am.
Yes, ma'am.
What is a Hilbert space? Inner product space plus completeness, na?
Yes, ma'am.
Implies norm plus completeness. So completeness is common in both. So which one implies which one? Every inner product space is a
Non-linear space.
norm linear. Okay. So every inner product space is a norm linear space because your norm is defined with the help of a inner product space. Okay. Whether you know what is a norm, what is geometric interpretation of norm, what it gives you, that means what is the difference between modulus and norm, because both are going to give you a distance.
Norm is giving distance from origin.
Correct. And modulus will give you distance between any 2 points.
Yes, ma'am.
So in the here we have defined for a numbers, rather it may be real or complex number. But what is the definition of norm? If you have a function, say norm of phi of x is nothing but inner product of phi with phi, that is nothing but the square root of this one. No? So which we can define as, now what is your inner product we have defined just now? Inner product is nothing but integration a to b phi bar of x and this square root as it is. So in this way we have defined our norm for a function. Now can anyone tell me what is phi of x into phi bar of x, just like z into z bar?
It's mod z, na ma'am.
Norm of phi of x square.
Mod of phi of x
Square.
square. Z into z bar is nothing but mod of z square, no? मलाही माहित नाही हा, तुम्ही व्हेरीफाय करा. It's so difficult, z into z bar. हे तर बेसिक आहे ना, कॉम्प्लेक्स मध्ये शिकलेत ना आपण.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So in the very similar way, we should know about functions. So here, what is a norm of phi of x, which we have defined with the help of inner product, and now we have applied the definition of inner product for a function, and then z into z bar is nothing but mod square of z, and hence we can say the norm of phi of x is nothing but square root of integration a to b mod square of phi of x. Okay. Now let me go for the next one. I hope this one also you know. सांगा, orthogonal, orthonormal, both you have studied in the functional. What is orthonormal? What is orthogonal? I think you have studied orthonormal vectors and orthogonal vectors.
If inner product of x and y is equal to 0, then x and y are orthogonal.
Inner product of then we say x and y orthogonal, right? Orthonormal means
The norm of this vector is equal to 1.
norm of x is equal to 1, then it is called a ortho. So here we define orthogonal function, that is phi which psi, it is equals to integration a to b phi of x into psi bar of x, which is if it is equal to 0, that is if inner product of these two, if it is equal to 0, then it is called a orthogonal. In general, we can say it is a perpendicular one. If we are having a perpendicular one, then we can have a inner product is 0, right? Why inner product is 0 if we are having the orthogonal or perpendicular vectors? For that, you must go back for, say, if you are having any two vector and if you want to define an inner product, our inner product is nothing but आठवत आहे का कुणाला? Inner product is nothing but the generalization of a dot product. So that's why we are going to dot product of any two perpendicular vectors. Suppose x is here. What is the dot product of these two vectors? X dot y is mod of x, mod of y, cos of x. Cos 90 is 0. Hence we say that dot product of these two is 0. When I inner product है generalization of dot product का है तो rather whether you know what is a dot product, that means dot product we have actually defined with the help of a projection means what? Savli, right? With the help of a projection we have defined a dot product, and with the help of dot product we have defined the inner product. Okay, so all these are related to one another. So what is a projection? It is simply an image. So with the help of a projection, we have defined a dot product, and Then what is the inner product? It is nothing but the generalizations of dot product. And hence we are saying that for orthogonal vector, the dot product, the inner product of any two vector, if it is equal to 0, then it is called a orthogonal vectors. Correct? Can anyone just say me whether you know how this generalization work for inner product is a generalization of a dot product? Okay, in the next lecture we'll see, but up to then you have to think on that. For that actually we have started with the numbers, that is 2 into 3. What is 2 into 3?
6.
How you calculated 2 into 3? Suppose we have the real line. Okay. Say this is from 0, 1, here is 2, 4, 5.
It's 2 times 3, ma'am.
So this is what 2, 2, 2. You can have this as 3 into 2 is equals to 6. So both are equal now. Just like you can say it is going to satisfy abelian property, commutative. So 2, 2, 2, 2, 3 times, or you can have another way, which is 0, 1, 2, 3, 4, 5, 6. So 3, 3. And this is 3. So combining these two, 3, 2 times, so it will give you 6. So with the help of this one, we have defined the dot product, and then we have defined the inner product. Try to think on this. So after this lecture, you will have the next one. I hope it is major and integration lecture. We'll share you new timetable because we are now going to conduct the practicals of first year. So that's why we have changed the timetable. Okay. Thank you. You may join the next lecture.
Thank you, ma'am.